All right, today everybody we're going to be talking about long division and synthetic division. What I'd like you to do is take problem number 1, put it into your journal, and we are going to be doing some long division. The good thing about long division is you can use it every single time to find if a factor goes into a polynomial. The bad thing about long division is it's long. The reason why they call it long division, yes. Alright? But then we're going to show you a faster way that you can use to be able to do this. But you can't appreciate the fast way unless you do it the long way. Get that written down nice and neat. We're going to start with multi-colors here. We're going to start with blue. I'm going to put a little blue box right here. And I want you to ask yourself, how many times does x go into 2x to the 4th? Which basically means this. What number right here times x would get me 2x to the 4th? We would say 2x cubed. Because 2x cubed, if I take this and do what with it? I multiply it to the x, what do you get? You get 2x to the 4th. And then if you take 2x cubed and you multiply it to the 7, what do you get? You get 14x cubed. Now from your days in elementary school, when you were doing division, what did you have to do with these? Did you have to add them together or take them away? That's right, so we have to take this right here. We have to take this whole thing, and we have to take it away. What is 2x to the 4th minus 2x to the 4th? Well, that's 0. Yeah. And then 14x cubed minus 14x cubed, that also cancels out. So far, both of these zero out, and so what are we going to do next? We're going to bring down a negative 2x squared, and we're also going to bring down a minus 14x. Alright, I'm going to go ahead and change colors here. I'm going to go to a nice red box. And you're going to ask yourself, how many times does x go into a 2x squared? It goes into it negative 2x times. Now if you're wondering what we're doing, we're trying to figure out what number right here, what number times an x gets me to a negative 2x squared. So I'm going to write negative 2x squared. What I'm doing is I'm taking this and multiplying it to the x to get this. Then I'm going to take this and multiply it to the 7. And what's negative 2x times a 7? Negative 14. Now, we're not going to add these together, right? We're not adding them. What are we doing? We're taking this whole thing away. A negative times a negative is a positive. So these are going to, once again, cancel out. A negative times a negative is a positive. So that's going to change this negative 14x to a positive 14x. And those, once again, will what? 0. So there's your answer. How many times does x plus 7 go into 2x to the 4th plus 14x cubed minus 2x squared minus 14x? Don't say that fast 3 times. It goes into it 2x cubed minus 2x times. That would be your final answer for number 1. Now, everybody, we're going to do number 2 as well. That's your final answer for number 1. Number 2, we're going to do long division one more time just to go over the process. So go ahead and do number 2 in your journal. Take your time. I hate the letter T. Don't tell it I said it. But when I'm doing math, I don't like T's. But I'm just going to do it because that's the problem. If you want to, you can change it to X's. Okay, here we go once again. We're going to start out with a box right here. What number right here, what number times t gets me to a 3t cubed? And you say, that's right, I heard you. 3t squared. So so we're going to take 3t squared and multiply it to the t and multiply it to the what? That -4, right? So we're going to multiply it to both of them. So 3t squared times a t is 3t cubed. And 3t squared times a -4 is a -12t squared. Well, what do I have to do to these, everybody? I have to take them away. Now these right here, what happens? Those totally zero out. But when I have a negative and a negative, what's that going to happen? It's going to change this to a positive, right? Which is going to make it what? Make this a 2t squared. Now what I'm going to do is I'm going to bring down this positive t right here. I'm bringing it down. And now I'm going to figure out the next number. What number times t gives me 2t squared? And you said 2t. I'll just put the plus right here. Okay. And that's going to be 2t squared. But then I also have to do what? 2t times a -4, and that's going to give me a what? -8t. Then I have to put this in parentheses and do a what? Subtract it. Okay? Now, when we do this, what happens to these right here? They zero out. But what happens when you have a negative and a negative? It makes it a positive. So now how many t's are we going to have? We're going to have a total of 9 t's. Okay? Because this negative and this negative make it a positive, and t plus 8t is 9t. Alright. We got to do what? We got to take that -5 and drop it what? Drop it all the way down. Is this feeling like long division right now? Because this is really feeling like long division. It's like long division. We're almost done then. We only have one more thing to do. Alright. Here we go. Last thing we want to do is we want to figure out what number times t is 9t. Yes! So 9, oh, can't see it. 9 times t is 9t. And 9 times a -4 is a -36. But once again, we've got to take it away. Man, I'd rather be golfing right now than doing this. Alright? So, this zeroes out. What's -5 minus a minus? Once again, that changes it to a plus. Oh, I know. It's okay. So that becomes a what? 31. Okay? So I'm going to go back here. So minus and a minus changes to positive. Uh-oh. We've got something called a remainder. Okay? So what do we do with this remainder? All right? So let's look at our answer. Remember, we have a 31 as a remainder. Okay? Here's our answer. You guys see that? What you're going to do, you're going to say, we have a remainder of 31 over our divisor. And what's our divisor? T minus 4. That's how you write your final answer. So your final answer, you don't have to put your final answer in boxes, okay, on your paper. Your final answer is 3t squared plus 2t plus 9 with a remainder of 31 over t minus 4. Now, let's see, we've been going for about 9 minutes now, just close to 10 minutes on this video, and we've done 2 problems. All right? Now we're going to do this a better way. We're going to do this problem using synthetic division. So right now, in your journal, I want you guys to write these exact same problem now, except we're going to do synthetic division. So here we go, clearing that out. here's what I want you to do. We're going to do it the book way. They like to put right here. The number that you're going to put in right here is going to be the number 4. That's what you're going to put in right there. You're going to put in the number 4. Like, where the heck did you get that? Well, this right here, everybody, t minus 4 is a factor. The number 4 would be considered a root. Because what does 4 minus 4 get me? 4 minus 4 gets me 0. Okay? So we're going to test to see if this number goes into it. So basically, some students just say, hey, if you see a t minus 4, you know you need to put a positive 4. If you see a t plus 4, then you put a negative 4. So right now, we're going to use a 4. The next thing I want you to do is we're going to label the t's. We're going to start with t cubed, then we're going to go to t squared, then t to the first, then t to the 0. How many t cubes do we have? We have a total of 3. How many t squareds do we have? We have a total of negative 10. There is 1 t in the problem, and there are negative 5 t to the power of 0. Just remember, t to the power of 0 is just equal to the number 1. Any number raised to the power of 0 is 1. $1 million in the bank account, awesome. $1 million raised to the power of 0, now you're down to 1. Okay? Now, next thing I want you to give a little space. Don't put this line right underneath. Give it a little space. Put a line right underneath it. Here we go. You're going to bring the 3 down. You're going to multiply the 4 times the 3 to get you to a 12. You need to know that you need to add these numbers together to get a 2. You multiply the 4 times the 2 to get an 8. You add the 1 and the 8 together to get a 9. You multiply the 4 times the 9 to get a 36. You add the 36 and the negative 5 together to get 31. Just know that if this is to the 3rd power, this is a cubic power, this right here is going to always be 1 less. So you know right now that you have a total of 3 t squares. Then you just go in descending order. This is t to the first. This is t to the 0. That's your remainder. Plus a remainder of 31 over, not x, sorry, t minus 4. Now, we're going to go back and look at the answer. You see this answer right here? That we had to take all the time and energy doing? We got the exact same answer using synthetic division. Just remember, when you're doing synthetic division, you're going to take this 4, everybody. This 4 you're going to take, and you're going to do what to the 4 for all these numbers? You're going to multiply. Okay, you're multiplying the 4 to all the numbers that you get after you've added. You add these, then you multiply. Then you add these, then you multiply. Then you add these. Whenever you're done, that's your remainder. Now, if it's 0, that means it goes into it perfectly. It goes into it evenly. So what we're going to do right now, we're going to go down to problem number 4. Let's go down to problem number 4. Now, we're going to do synthetic division now. We're going to do synthetic. Same thing. We're going to do synthetic division. Right now, what I want you to do is, this is not how the book does it. This is how I set mine up. You can do it however you want, all right? I set mine up, I label it into the 4th, in cubed, in squared, into the 1st, into the 0. All right? If that says n plus 2, I know I need to use a negative 2. Then I ask myself, how many n to the 4ths do I have? I've got 1 of them. Here I've got negative 1, because it's a negative n cubed. Here I have a negative 10n squared. Here I have 4n, and here the constant at the end is a 24. So I always put them in descending order. Now here's something that could happen, all right? Let's say, for example, you don't even see this right here. This right here is not there. Let's say that wasn't there. You still would have to put a, if there was no n squared, you would still have to put a 0 as the spacer. Okay? So if you don't see one, you still have to do it in descending order. Here, everything is 4, 3, 2, 1, and this right here is your n to the 0.
Why negative?
Why negative what? Oh, just remember, what number plus 2 gets me to 0? What number? Negative 2. That's how you do it. Always ask yourself, what number plus or minus that gets you to 0? That's why I'm using a negative 2. First step, drop it down. What am I going to do with all the numbers that are down here? I'm going to take these numbers and multiply it to a negative 2. What's negative 2 times 1? Negative 2. What am I going to do with the negative 1 and the negative 2? Make sure you know that you need to do what? Add them together. You add them together and you get negative 3. You multiply this together. What do you get? Negative 2 times negative 3 is a positive 6. You add these together and get negative 4. Negative 2 times negative 4 is a positive 8. What do we have to do now? We have to take these numbers and add them together. Now, when I'm doing this problem, I don't write the word add all the time. Okay? Just remember you need to add them together. Multiply negative 2 times 12. I'm getting excited now. I get a negative 24, and now what's my remainder?
0.
0. That's good. That means that this is indeed a factor of this. Well, how much does this go into all of this? Remember, if this is n to the 4th, that means this tells you how many n cubes. If this is n to the 3rd, this is a what? N squared. All right. This is n to the 1st. This is n to the 0. And this number is my remainder. If your remainder is 0, that means it is a factor. If your remainder is not 0, that means it's not a factor. Okay? Call this the remainder factor theorem. There you go. So we have n cubed minus 3n squared. It's kind of like an algebra 1. When you finally figure out that slope-intercept form gives you the slope and the y-intercept. It's like, wait a second. That makes sense. That's why they call it slope-intercept form. They don't call it oogly-boogly form. All right?
Why n cubed not n 4?
Well, because if this is n to the 4th, okay, this is always going to be 1 less. Because what is n cubed times n? N cubed times n is n to the 4th. I'll explain. Let me finish writing the answer, then I'll explain to you and make more sense. So everybody, this is your final answer. Now let me explain to you, because Blue has a good question here. If I take n plus 2, and I multiply n plus 2 times n cubed minus 3n squared minus 4 plus 12. If I took this and took the time and energy to multiply those two, this binomial with this polynomial, if I multiply those together, you're not going to believe what your final answer would be. It would be n to the 4th minus n cubed minus 10n squared plus 4n plus 24. These two factors multiplied together gives us our original problem. Look at this right here, and let me scroll up. So n plus 2 times this gives me what? All of this. Okay? That's why it has to be an n cubed. If it wasn't an n cubed, then what's n to the fourth? What's n to the fourth times another n going to give me? It's going to give me n to the fifth, so that wouldn't make any sense. Okay? So what's your final answer? This is your final answer. You don't have to do a remainder of 0. Okay? That's your final answer. What I want you to do now is I want you to do synthetic division on 3, 4, 5, and 6. This is already a 4. Let's do 3, 5, and 6.